In this video, we're going to be looking at quadratic inequalities. And if you haven't seen my previous videos on quadratics or my previous videos on inequalities, I'd recommend you check out those videos first, because this is just going to build on the concepts that you've already learned from those videos. So let's get straight into it. Let's say we have a function of x, like such, which is equal to x squared minus 4x minus 5, okay? Like such. Now, I'm not going to solve this quadratic expression because we should know how to do that already, and all I want to do at this stage is to show you some key principles about quadratic inequalities. So I'm just going to quickly give you the solution to this quadratic, which is x plus 1, x minus 5. And we can therefore draw this this quadratic graph. So we're going to put a y and an x line here, and we know that it's going to cross over at -1 and at 5, okay? And it's going to have a U shape because our coefficient of x squared is positive. We can imagine there's a 1 here, and that will look something like this, okay? Beautiful. So the solutions to when x squared minus 4x minus 5 is equal to 0 is where it crosses over the x-axis, and these are called our critical values. So the solutions to the f of x equal to 0 is -1 and +5, okay? Now what happens if we have an inequality? So if x squared minus 4x minus 5, instead of being equal to 0, we put it's greater than 0, okay? What would be the solutions here? So these are, the solutions to this are the x values when the curve is above the x-axis. It's greater than 0, it's above the x-axis. So this is the area over here and over here, okay? So we want the solutions which where x is less than -1, so that's that part, but we also want x is greater than 5 too, okay? So those are our solutions when x is greater than 0. These are the regions that we're dealing with, okay? Now how about we flip the inequality and we write, instead of greater than 0, this time we put less than 0, okay? And to solve this, that is the region where the x values when the curve is below the x-axis, okay? And we're talking this little region in here, okay? And therefore we're looking at, it's between -1 and 5, so it's going to be x is greater than -1 or x is less than 5, okay? And because it's a region like that, we can just write -1 x 5 because it's within that region, within that range. Okay, so that should give you sort of allow your brain to sort of identify and see how these sort of quadratic inequalities work. So let's actually look at an example. And this time we will solve the quadratic formula just so that we know what we're doing. So let's get rid of that as well. So let's say we are told to find the set of values of x for which 3 minus 5x minus 2x squared is less than 0, okay? Now the first thing we want to do is just make this into a quadratic formula. So what I would do is just set this equal to 0, 3 minus 5x minus 2x equals 0. That's something that we should be familiar with now. It's our classic quadratic equation. And just to make this easier for ourselves, we want to make sure that we have more positives than negatives, and it's helpful if we have our x squared coefficient, which is -2, as a positive. So what I'm going to do is multiply by -1, so it's easier for us to factorize. So -2x squared multiplied by -1 is 2x squared, minus 5x multiplied by -1 is positive 5x, and 3 multiplied by -1 is -3, and that's equal to 0. Okay, and so at this stage we just want to solve this as a classic quadratic equation. So we want to find a number that multiplies. So imagine this is A, this is B, this is C. We want a number which multiplies by A times C, which is -6. And we want a number that adds together to make 5. So two numbers that multiply to make -6, and the same two numbers should also add to make 5. And we can, let's have a little think. We got -6 and -1 would do. Obviously 6 plus -1 is 5, and 6 times -1 is -6. Okay, so what we want to do then is just plug this into our formula. So that gives us 2x squared plus 6x minus x minus 3 equals 0, sorry. And then all we want to do is factorize each half separately. So we can have 2x squared plus 6x. Well, we know that 2 would go into both because 6 can divide by 2, and so can 2. And x is also in both, so we can do 2x. And then to make this into 2x squared, we just multiply 2x by x, so that's 2x squared plus 3, because 3 times 2x is 6x. Okay, and then we want to do the same over here. Well, we could think that -1 could probably go into both, and that way we got -1 times x is minus x, and then plus 3, because -1 plus 3 is -3, and that equals 0. And then just to rewrite this expression again, just so it's easier in our mind, 2x minus 1, x plus 3 equals 0. Okay, so that is our quadratic. And just so that we have the solutions here, if we want to find the solution to this, 2x minus 1, so let's say we have 2x minus 1, that's too small, sorry, 2x minus 1 equals 0, and to find the solution we just want to get x by itself, so 2x equals 1, therefore x equals half. Okay, because we can just add 1 to both sides, then divide both sides by 2. That gives us x equals half. So I'm going to write this over here. Let's move this out of the way. X equals half. And the other solution, obviously x plus 3. X plus 3 equals 0. And if we take 3 from both sides, that gives us x equals -3. And so that is our other solution for x. And in other words, these are the points where our graph is going to cross the x-axis. So let's now draw out this graph. I'm going to keep the original expression at the top of the page and also our two solutions of x. So if we were to draw the graph, we can have our y-axis and our x-axis. Excuse the lack of straight lines. I would recommend you use a ruler. And then we want to know where it's crossing the x-axis. So we've got a point at half here, and we've also got a point at -3 over here, okay? And as we had originally a negative coefficient, we're going to get a graph shape that looks a little bit like that. So it's going to look something like this. That should cross over at the half point there. Okay, so that is the shape of our graph, and we can now work with that to work out our set of values. So we're looking for an expression where it is less than 0, okay? So now we've got to remember that the outer parts of the graph below the x-axis are the points that are, less than 0 here. So we're looking at this region outside here, because remember, this is our point of reference, the x here. If x is greater than 0, then we know we're looking inside this point in the middle here. But if it's less than 0, then we're looking outside of our graph, outside the arms themselves, okay? So the required set of values would then therefore be x is less than -3, because obviously we're in this region here, we're moving that way, and x is greater than a half, okay, like such. And they would be our set of values for which 3 minus 5x minus 2x squared is less than 0, okay. Let's have a look at a second example. If you have any questions about any of this, just leave a comment below and I will get straight back to you as soon as I can. So let's say we have to find the set of values of for x for which 12 plus 4x is greater than x squared. Okay. Now, the first thing that we really want to do here is to make sure that we have, our expression on the one side and we have 0 on the other side. So we're going to add we're going to want to keep our x squared coefficient, wherever possible, we want to keep the x squared coefficient positive. So here it is positive. And so what we're going to do is take this from both sides. Okay, so we're going to have x squared minus 4x. Okay, so that will take it away from there and add it to this side. X squared minus 12, so it takes it away from this side and puts it over here. And then this side is just going to be 0, like such. Okay, this should be x squared. And at this point, we now have a quadratic expression that we can solve. And I'm just going to rewrite this. So I'm just going to rewrite this one. It's exactly the same, but I'm just going to put the actual quadratic on the left-hand side instead of the right-hand side. I don't know why, I just feel like it's easier to solve. Okay, so that is what we had a moment ago, like such. And we're just going to solve this as per normal. Okay, so we want to find a number, or two numbers that multiply together to give us negative 12, and two numbers that add together to give us negative 4. Okay, what two numbers could those be? Well, minus 6 and plus 2 look good to me. Minus 6 times 2 is negative 12. Minus 6 plus 2 gives us negative 4. And we're going to plug those two numbers in place of our negative 4x here. So we're going to have x squared minus 6x plus 2x minus 12 is less than 0. And what I would probably recommend you doing here, just to make it easier, is just to set, instead of putting the inequality sign in there, just set it equal to 0, as we did in the previous example. Okay, and if we were to then solve this equation, so I'm just going to do this a little bit quicker, we can have x minus 6 plus 2x minus 6, okay, which gives us our solution. Well, simplifying this down is as such. Okay, we've got x plus 2x minus 6 equals 0, which means that our solutions are, if we set x plus 2 equal to 0, that means that x is going to be negative 2. So we've got x equals negative 2, and x minus 6 equals 0. We can add 6 to both sides, that gives us x equals 6. Okay, and so as before, we want to then sketch our graph. So let's say we're sketching it down here. Draw your y-axis, draw your x-axis like such, and try to label them. And then we know the points where it's going to be crossing over is x equals negative 2 and x equals 6. Okay, and we know that as we have a positive coefficient of x, as this should be 1 for example, we're going to have a sort of U-shaped like that. So we can draw this like that. Let's just extend that down. So we get a quadratic graph. I don't know why I did that. We get a quadratic graph that looks like that. Okay, and at this point we want to actually solve the inequality. So we know that x squared minus 4x minus 12 is the inequality. It's the same as what we had originally, but we just rearranged it into our own inequality. And so we're looking for the places where it is less than 0, okay? Less than our reference point here. And this region in here, which is captured by our curve, is what we're looking for. So we're looking for the region that is greater, x is greater than minus 2, and x is less than 6, okay? Which can also be written as minus 2x 6, okay, and that is our solution, okay, because it is within that given region there. Okay, and let's look at one final problem. And that should be a good place to stop, I think. So how about we need to find the set of values for which 6 over x, okay, is greater than 2, and we're going to say x is not equal to 0. Okay, this looks a little bit more complicated. Now, watch out here, because x could be either positive or negative. We don't actually know, so you can't just multiply both sides of this inequality by x. Okay, it would be a common mistake for people to think, okay, well, you know, I can put x up here by just going 6x. 6 divided by x times by x would be 6, and that's greater than 2 times by x, and then they'll get to this sort of solution and then work out from there. I'm not too sure whether this pen's very good, but I think you can see what I'm trying to do here. So this wouldn't be the right way to do it, because x could be either positive or negative. So let's cross that out and ignore that. Instead, we want to multiply both sides by x squared, because x squared is never negative, and x is not equal to 0, so x squared is not equal to 0, and the inequality sign will stay the same. So let's multiply both sides by x squared. So if we multiplied 6 divided by x squared, we're going to get something like that, and then we can cancel out 1x, so that's going to give us 6x is greater than 2 multiplied by 2x squared is going to be 2x squared. Okay, and as before, we want to move the everything to one side, so let's just take 2x squared from both sides. 6x minus 2x squared is greater than 0, and as before, it's always easier just to try and set this equal to 0, so it's going to have 6x minus 2x squared is equal to 0, so we can now work with that as a quadratic equation, and we want to solve this corresponding quadratic equation to find the critical values of x. So here I would factor out an x, so we've got x, and that can give us 6 minus 2x. So factoring out an x from this equation will mean that we can set x equal to 0. So that gives us one of our solutions, x is equal to 0. And 6 minus 2x equals 0. Well, we can say that 6 minus 2x equals 0, which means that 6 is equal to 2x if we add 2x to both sides, and 6 divided by 2 is 3, so x equals 3, and that gives us our second solution there. Okay, so what we want to do then is draw a graph of this. That's always what you really should be doing, is trying to draw a graph so you can sort of visualize what you're doing. And also note that x can be equal to 0 even though x is not equal to 0, but it would not be part of the solution set even if the equality was x is greater than or equal to, or just greater than, so just bear that in mind. So we're going to sketch this graph like such. This is going to be our y-axis, and this is going to be our x-axis, y and x. And then we want to put, like, we got the 0 down here, this is our origin down there, and we've also got 3 over here. And I've now got rid of it, but if you remember, we had negative 2x squared over here in our formula, so we're going to have a down, n sort of shape to our graph, so it's going to look something like that. And we can now work with this to solve our solution, our inequality. So we were looking for, in fact, I'm just going to write out what we had before. The expression was 6x minus 2x squared is greater than 0. Now, as you can see, our coefficient of x squared is negative, so it's going to have this sort of n-shaped to it. And we're looking for the regions in which it is greater than 0, okay? So obviously if we take this as our reference point, we want it greater than 0, so it's going to be in here, captured by our graph, and therefore we're looking for places which are x is greater than 0 and x is less than 3, which means that our final solution would simply be 0, x, 3, and that means it's within that region, and that is our final answer. So yeah, if you have any questions about any of this, then please leave a comment below and I'll get straight back to you. There'll be new videos almost every day, so make sure you subscribe to my channel, and I shall see you next time. Thank you very much for watching.